This conference will now be recorded.
So there's only one problem, and the problem is how to make how to make data persistency. Okay, that is a event uh, beyond the life cycle of pod, beyond a life cycle of the pod. In simple way, pod is gone. We know that pod is inferior. So pod is gone, and then the data which is stored with the pod, processed with the pod, should not be lost. Okay, and how can we make sure that the we should not lose the data, and the replacement pod should have that data, and that way data persistency can be maintained. So that is the problem which you have. The answer is in a simple word, which you call it a volume. Okay, so this is similar to Docker volumes. Okay, we have a volume concept in Kubernetes as well. So now here volumes, which is basically is like attaching the volume to the pod and mounting inside the container, and then keep the data in the volume. So if the pod is gone, data is not gone. So how do we get started? So basically, there is a different types of volume which you can create. Different types of volume. Okay. Now this volume concept, we call it PV. Volume is equal to PV. PV stand for persistent volume. Okay. So here when I say types of volume, types of PV. Are you getting my points?
Yes, sir.
Yeah. So now how do we know what are the types of volumes which you have? So depends on the storage technology. Primarily, if you look at this, we have three types of technology in storage, which we broadly use it. One is a block storage. One is a file storage, which you can also call it network storage, and third one is object storage. So how do we know the types of PV? So just let's Google it. And persistent volumes here. So if you go to this documents, the official documents, and spend more time on the official documents, because during the exam you can access it, this all this stuff. So go down, and here you have some of these. These are some of these types of PVs. Some of this. Now little bit go down and we'll see few more. Here it is. So here I think these are the older one which got deprecated. So now in fact, yeah, you know that this is also deprecated. Uh, so they must be having some replacement. And these are the one which you can refer it. Okay. Here this is the active one, and here this got deprecated. Okay, so and this got removed actually. Now the following types of persistent volumes are deprecated. Means deprecation means they will remove in future, not removed now. It will remove. This means the support is still available, but it will be removed in a future of Kubernetes. At least. So now what exactly these are? So these are the type of PV which is supported by Kubernetes. So I'll put it in this way. If you want to keep the storage on AWS, so you can use this one. If you want to keep the storage on Azure disk, this one, Azure file, OpenStack Sender, here it is. vSphere volume, here it is. Now some of these are still in support. For example, chef's volume, FS volume. This is the files system volume, which is governed by CNCF. This is something which I'm going to show you now. What is this? So this volume type, when you use it, the volume will be created in the same host where the pod has been created. Did you understand that?
Yes. Like
Yeah.
affinity, you mean? Like on the
Volume
same
will
node.
be create same node where the pod has been created. So this has a limitation. What limitation? So if the next time the pod is created in the next node, then this is waste. This is just for learning purpose. It's not supporting the multi-node cluster. It's only for the single node cluster. But if you want to have a multi-node clusters, then this NFS you should use it. Network file system. So yeah, these are the types of volumes, persistent volume, which is supported by Kubernetes. Okay, so you should practice host path, you should practice local, you should practice NFS. So these three are sufficient for the project uses. AWS, Azure, Google Cloud, and vSphere depends on where your project is running. Okay, so these are the things. So now we got to know. Okay, these are the types of volume which you have. Now the question is how to get started. Okay, that is a question. So how to get started? So first thing you have to become an admin. Okay, and second thing you have to become a user. Here admin means administrator of the cluster who create a volume pool. Remember, I'm saying pool. Pool means multiple volumes for the users. Okay, and user who request and use it. For example, I'll give you some examples in a simple way. Uh, all of you, I am assuming you know that AWS, right? AWS.
Yes, sir. Yes.
Hello. Yeah. So
Yes.
in AWS, what you do, you log in and request the volume, create a volume of 10 GB, correct? But you create a volume of 10 GB only and only when AWS team, which is you can call them admin, have made it available for you, correct? So same way, Kubernetes is a platform. So Kubernetes is a platform. So someone has to make it infrastructure. Infrastructure means CPU, RAM, storage, and then you will use it and you will run the pod. So these are the two things you have to get it done. Someone has to create a pool and someone has to request for it. Now the question is how the admin will create a pool. So the admin will create a pool using the PV. Okay, this is the one of the resources, API resources. I'll show you the demo. Admin will create a pool like a multiple pool PV. Now the PV is a cluster-wide resources. It's not namespace specific resources. Cluster-wide resources. Now how users will request and use it? So users will request using PVC. So in a simple way, if you want to add a pool of volumes, admin will do that. PV resources persistent volume resource name, they can use it. If as a user you want to allocate the volume for the pod, then you will use the PVC. Is that clear? PVC means persistent volume claim. Is that clear?
Yes. Yes.
Okay. So now these are the things has to be done in advance. So here this whole process can be done, creation of PVs and PVC can be done in a two ways. Okay, one is static provisioning, and one is a dynamic provisioning. So now what is a static provisioning and what is a dynamic provisioning? So if you see that document, this one, please read this. Spend good amount of time actually. You will learn lots of things here. Okay. So here, what is static provisioning? Static provisioning, where PV is created in advance. Okay, PV is created in advance. Static, that's a static and manual, whatever you want to call it. PV is created in advance. And here at dynamic provisioning, PV is created based on request. Based on request. That is important. Static, dynamic. So dynamic provisioning, PV is created based on request. So this way you have to have that much of infrastructure in advance and you have created it. Here when user request through the PVCs, then PV is created. So request means PVC. So this is a dynamic one. Okay. Now for PVs created in advance, so that's a manual. This is automated. Dynamic means PV is created based on request. So how this PV is created based on the request? So for based on the request, they use one more resources, and the name of the resource is called storage class. Okay. So here, how many resources we have learned? One resource is PV, one resource is PVC, and another resources which is for dynamic provisioning is storage class. Did you understand that, all of you?
Yes.
Yeah. So this is the two types of provisioning. Now, next thing is workflow. So workflow with static provisioning and workflow with dynamic provisioning. Okay. So now let me tell you step by steps. You'll not forget. Step number 1: create a PV. Okay. It will be done by admin. Step number 2: create a PVC. This will be done by user. Step number 3: attached PVC to pod. And then step number 4: mount inside a container. This is something which you have to do that. Understood that, all of you?
Yes.
I'll put it in a very simple way. Let's say you want to add more storage to your laptop. So what do? You go and buy the storage in the from the market. That's called step number 1. Then what you do? You pay them and you claim them. Okay, so that's the step number 2. You create a PV means you have a shop where you have available hundreds of PVs, hundreds of storage, but one of the PVs you buy it from them, correct? So you claimed it. After that, what you'll do? Attach to the laptop, and after that, mount in somewhere E drive or G drive, and then that is something. Then you can use it. The same way you can think of it. Make sense?
Yes.
Okay, so now how do we have the dynamic provisioning? So dynamic provisioning, here what happens? First thing, because I said PV is created based on the request. So first thing happen, create a PVC. Now when you have a create a PVC, then it will request the storage class. Okay, so step number 2, create a PVC, call storage class. Storage class for PV. Now PV is created. Step 3, PV is created. So step number 1, step number 2, step number 3, and after that attach the PVCs to pod, which is 4, and then 5. The only thing which happens is because here PV is not available. So create a PVC, and PVC will call the storage class. Storage class will create a PVs, okay, and then attach the PVC to pod and mount inside a container. Are you able to understand this?
Yes.
Okay. So now let me show you this one. Okay. How do we get started? So PV, PVC, and blah blah blah. So I have some sample program for demo. So here, this is storage class. This is a NFS server you need it for this, but right now I don't have. Host path is easy to display. Okay, look at this. So first step, what do you want? PV. So guys, kind is equal to PV. Okay, and what is the name of the PVs? Host path. And here you are creating manually, not through any storage class. How much of PVs you are creating, and where the PVs is creating, where it will be created, this location. So this is your PVs code. Okay, so let me log in. Okay, so here mkdir Rajesh, cd Rajesh. So first let me check the PVs is there or not. So kubectl get PVs. See that there is no PVs at the cluster level. So vi pv dot pv1 dot yaml. Now name I'll make it one here. Now there's one more PV I'll create, and this is a 2, and this I'll make it of 2 GB. So one I created 1 GB, another one I created 2 GB. So can I apply PV have PV1 and PV2. Now guys, if you look at this kubectl get PV, see here 2 PVs are available. It's a pool of PVs. Who is doing this work? Admin will do that. So here it's a 1 GB and it's a 2 GB, and you see status available. So far so good, all of you.
Yes.
Okay, so
What is
now
RWO mode?
so this is the access mode. Read write and O for CI when I forgot. So read write and uh, read write and O for uh, what? Once, read write once.
Read
Okay,
once.
okay. ROX is a shortcut. Read only many, read write many, and read write once pod. So these are the access mode, what access you have given. Default is read write once. So that is something which we have. So I got this pool created. So if you look at this step, this is done. Now someone has to claim it. So claiming it, that is done by user. So how do I claim it? So for that, look at this. Kind is equal to PVC, and how many GBs you are claiming? 1 GB. And So copy this, vi pvc1.yaml, and I'm claiming 3 GB. Okay, mind it, I'm claiming 3 GB, whereas the pool is you have 1 GB and 2 GB. So kubectl get pvc. Now pvc is a specific to namespace. pv is a cluster wide resources, pvc is a namespace resources. So do you have anything in the default? No. So can I create the pvc? So I'm requesting as a user kubectl create, apply, whatever you want to do, hyphen a pvc, done. Now I have created. Now if you see that here, and look at the PVs also, this PVC is pending. My PV is still available. That means why is pending? So if you describe this, all those commands, you know that. So you describe this PVC, then you will get to know, okay, you are demanding 3 GB, but there's no PV is available of 3 GB. 1 GB is available, 3 GB is available. So now if you, let's say if you have 1 GB and 2 GB, okay, and if you demand 1 GB, one of which you will get it. If you devise 2 GB, this one you get it. Let's say if you have both 2 TGB and you demand 1 GB, one of these will get it. So basically whatever you're demanding, the pool size should be equal or lesser than that. But right now none of this pool we have, PVs we have, which will satisfy the requirement. So now what I'll do, I'll create one more PVC, and this I'll name it VIPVC2.yaml, and this I'm demanding only 1 GB. So let it be. Name I have to change it, and you see here one I change it, mind it. You see here apply hyphen f pvc2.yaml. So now you see that here get PV. See, this is bounded to what? See here,
Ospath 1.
this is the 1 GB I'm demanding, bounded to 1 GB. So here what I did this one. I created a PVC. That means I've started. Sorry. So I have claimed that PVC already. One of the PVs through PVC. All of you are understanding?
Sir, in the storage class, we are defining manual, no? So what it signifies actually in PV?
So storage class, because I'm doing static, no. So this static means there should not be a storage class name. But if you are doing dynamic, then you have to give the name of your storage class here. Manual means static.
Okay, because storage class means I think some some storage of your computer or something, no? Because we
Storage
have to
class.
define. Mm,
Storage class means, see what I did. Look at this here. When you
the
create a
manual
PVs,
mm,
uh, when you create a PVs, then you define the type of PVs. Correct now? Host part.
correct. Mm,
So here storage class, what exactly you are doing? You are creating a storage class with these many types of storage, and during the dynamic creation, you can call that, and automatically it will create any one of these. Okay, for example, I'll show you that storage class in some time, 5 minutes. Let me
mm,
complete this flow first, static one. Okay,
okay. Mm,
so here I did created a PV and then PVC. Now I'm going to attach to the PVC to the pod and mount inside the container. How do we do that? It's very simple. Look at this. What do you want? Pod. This is the pod container. Now if you see that here, pod.spec.volumes and attaching the PVC here. This is called attachment. So if you have attached this PVC in a volume to the pod, you can use inside any containers. I repeat, you can attach the PVC. Let me show you one image. I have a slide, but I don't want to use it. Pod PVC. Okay, never mind. Let me use my own. Look at this image. You'll understand that. So see that here 3 volumes is attached to the pod. Now if you look at it very carefully, you are able to use each volume inside a container, mount inside a container at a different path. Are you able to understand this?
Yes, sir.
Yeah. So here, if you look at this, you have attached this volume PVC to the pod, and now you are, look at this, pod.spec.containers.volume mounts, and you are mounting this. This is the PVC which is here. I'm mounting inside a container at this place. That means anything which is stored here, that will be persistent. Even the pod is deleted, the data will be there. Understood, all of you? So this is called attaching. This is called mounting. All of you? So let me show you the pod. So here pod.yaml, and here I have to give the name of my PVC, and my name of the PVC was 1, PVC path 1, which is here. So 1, done. kubectl get, not get, apply -f pod.yaml, and kubectl get pods. See, this is creating. Just wait for a few seconds. Now it's taking a little time. Let me describe this. Oh, it's pulling images. No problem. Yeah. So now running. Now I want to remind you. You have to describe and then get the information done. The command and all, you know that CRUD formula. So if you see that here, this is the container, and somewhere downside here is a volume, and why the issue is coming? Oh, issue is because I installed issue. Okay, and here it is a, this one. Understood, all of you? Hello.
Yes.
Okay, so now what was the locations in this? So anything which I stored here in this container, it should be persistent. So can you check this? kubectl get pods, kubectl execute task pv, and inside this I'm going to create a one file. So touch index.html. I created a file for information. You'll see this file is here. Okay. I want to show you that file to that worker node also where it got created. So nodes -o y. This is the IP address, right? So quickly and root Rajesh123 Rajesh123. Now what I was trying to do is in the PV section it is created under this locations. Here. See that index.html is there. Understood, right, all of you? Now I will delete this part. I'll delete this part. And data is index.html, mind it. So kubectl get parts and delete pod task pv done. I deleted the pod. Data should not be going. So let me check that. See here, data is still there. Now if I create a new pod against in place of that new pod, look at this. I created new pod and now see data is still there in the new pod. They're mounting to the same PVC. Got it, all of you?
Sir, where did we mention temp DevOps school path for the node?
Which temp?
This was the
Oh,
path
okay,
on.
okay, okay, okay. PVC created. No, this was host type, host path, and this is one. Host path is a driver, which say one of the type of PVC. This will this using host path, you will save the data in the same host where the pod is running. You got it? I'm audible,
Yes,
guys, all of you?
So in
yeah,
this
yeah.
case,
So,
I
sir, this
believe we
path,
use.
like for like, let's say if you have multiple nodes, so will this path be available for all of them, all of the nodes?
No, 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 no. So you, it's a pool, right? So it's, I created only one. So this will be 1, 2, 3, 4, 5, 6, like that.
Okay, okay, fine.
It's a pool, right? PVs is pool. So you'll create a more pool actually, different path. This is a two pool I created, no, initially. See, so you will have a multiple. It's a static way, just for explaining purpose. Static way means I'm creating advanced and so on. Understood? Okay.
Yes, yes,
So
yes.
now I'm going to teach you dynamic way. So how the dynamic way? Not much different, same code, but little bit of workaround. Storage class. So let me show you. See here. Example code for storage class PVC and local persistent volume. Here example code for storage class PVC and host path. Let's use a host path. So here you see, first thing what you need to do, set up NFS server. Without it will not work. Second thing, set up a persistent volume of NFS type. So that is something which you have to do. See that what you want, storage class, and storage class name is fast, and here provisioner is host path. That means every time PVC is called, look at this. PVC is called, it will call the storage class, which is this one, fast, and fast will call host path automatically, dynamically it will create it. So here you see PVC, and here you have to look the storage class name is equal to fast. It's not there, but let me show you one more example. So here what you have, storage class. What is the name of it? Local storage. Provisioners is no provisioners. Here stateful set. Stateful set I have not explained it to you, but stateful set is like a deployment but for the storage. So deployment is for the static content. Stateful set is for the dynamic content. I'll talk about later. But you see that stateful set here. Here you are calling the PVC template, and this is spec for it, local volume. Here you are creating a mount, and this PVC is local storage, which you are referring to here, storage class name. Are you understanding? Okay. So this is the way you can achieve the persistency. In the real time, in the project related topics, basically we use EBS, Azure Desk, and Google Cloud. If you're on Google Cloud, you use the Google Cloud. If you have a private data center, we use CEF-FS. So that is something which we do in the real time. For the trying purpose, you can play around with the host path and the local. These two volumes will be created uh, in the node where the pod is running. Got it, guys? All of you?
Yes, sir.
Okay. Any questions so far? Okay, so let's have a 5 minutes of break, and let's after that break, we will cover the few more resources, which is daemon sets and stateful sets and all. So two important resources we have, which we'll cover after the break. Will that be okay?
Yes. Sir, can we make on AWS platform this NFS wala thing? NFS.
For that, you have to have a EKS cluster actually. So without EKS cluster, this cluster, the one which
Yeah, I
I
knew. Yeah.
set it up, will not work for that. So you need to have a EKS cluster, then only that permissions and all will be managed for the PVC. You cannot do directly. With this cluster, it will not work.
So will it cost if we try on AWS?
Yeah, around $30 to $40 for EKS cluster.
This conference will now be recorded.
Okay, so two more resources which I want to talk about. One is daemon set, okay, and another one stateful set. Now, but before that, let me show you some code for this one, GC. I mean, sorry, AWS. So for that, what we need to do, uh, it should be up. Where's the code? It's not finding. So PV, EBS, Kubernetes. Same page actually is taking me. No. Okay, let me see if I have some example on my blog. PV, EBS. So look at this code. Rahul, you had asked this question, right?
Yes, sir.
So same thing here, kind is equal to PV. How much capacity? 5 GB. Now here, what you are doing, elastic block storage, volume ID. So here what you have done, created a 5 GB and then volume ID you get it from that. And here you are putting up. And file type, FS type, you are setting up FX3. That's all. So this will create a PVs on EKS cluster.
Okay. Sir, volume ID from where we are taking actually?
Volume ID will be, this is a static one. So you have to feed this. If you don't want static one, then you have to create a storage class with a EBS. That's told you, no, two types of it,
Yes,
static
yes, yes.
and
Generally,
dynamic.
we don't
So,
use static only. Nobody use static now.
so in the dynamic one, what you can do, I'll show you the example for this. So EBS storage class. A lot of examples you'll have it for that. Let me see if I can quickly locate. Hmm. Yeah, here, this is the perfect example. Look at this. So here the name of the static 2 is, dynamic is GP2. So here you see storage class and provisioner is EBS. Look at this.
Okay.
Okay. So now this name has to be used in the PVC, this one. So look at this here. This is only SC. Got it?
Okay.
So like that you have to create it. So this in this dynamic one, it will, when you create a PVC, then it will call the storage class. In this case, this one, and this will create a GP2 EBS volume, and then then PV will be created and attach PVC to the pod and mount it inside of it. Okay, so now there is one more daemon set. So guys, let me tell you, there is a many ways to deploy the pod. So one of the kind which I taught you is a pod itself. Then I taught you replication controller. Then I taught you replica set. Then I taught you deployment. So all of you are comfortable with it, right? Hello?
Y- yes, sir. Yes, yeah.
Yeah. So now I'm going to teach you daemon set. What is a daemon set then? Just like one resources for deploying the pod, but it has a certain rules. Here rule is very simple. One pod, one node. Did you understand that? When you deploy the daemon set, when you deploy the pod using daemon set, then using the daemon set, there will be only one pod will be deployed per node. Okay, here let's say if you set the deployment number 10, deployment pod replicas number 10. So it will deploy no matter irrespective of how many nodes you have it, it will deploy a number of pods. But here it will deploy one node, one pod, one node only. So then you ask Rajesh why, what are the use cases for it? So use cases are like monitoring, implementing the networking driver, implementing the security and all stuff like that. So do we have a daemon sets already installed? Yes, we were having actually. So let me show you. So go to this kubectl get ds daemon set hyphen all. Where I am? Sorry, I'm writing on the wrong one. So here kubectl get ds hyphen a. See here. Any idea what these two ds is doing here? All of you? So this is the kube proxy networking pod, and this is the driver pod. So you have two nodes, right? Sorry. So that's the reason you see that one and two. So you have two. Got it?
Sir, why two? I didn't get.
Why two? Because one pod, one node, each pod,
Okay.
each node, one pod. So two node, two pod. You have it.
Okay. Sir.
This will make sure that. So this is for maintenance, administration work, logging, tracing, installing some agent in each node. You can do that actually. So how do you do that? A daemon set. So mm, that's not a big program actually. So just search for daemon set. Think there's a problem in search. A spelling mistake. Please remember that. Ah. So here what you want, daemon set, and specify the what container you want. That's all. So this will make sure that it will install the one pod at each. Let me deploy and see that. So vi bs.yaml. In the master, I doubt that will be deployed. Let me check. Why I'll tell you. This is the engine export, okay? There's a problem, and the problem is okay. So this code, if you see that, this code is this API version is outdated. So what to do? So kubectl API version right now versions S. So locate that daemon set. I think it should be extension alpha 1. So what was that? Beta 1. So this is the one. Okay. So oh no, that's the HTTP. Sorry, my bad. I'm reading
Should be
something
something
else.
networking.
Yeah, let me check. API resources and grep BAE. BAE. It's apps v1 now actually. So this is migrated to apps. So I have to change my code. Like this, you can fix the old code to the new code. Okay. And now deploy this to. There's some problems. Okay. So this whole code has to change. So let me do one thing. Let me try this one because this is the one. So with the older releases, you have to deprecate the code that is you should get from the official document. Command line also you can use it for creating, but I want to bring that YAML in practice. That. So now kubectl get pods hyphen a. It's very difficult to do that. So get ds. So right now I created only one. The region is very simple. Last time when I showed you, this is 2, and this the region is different. Here the region is different. So why it's coming only 1? So understand that here kubeproxy and VNet pod is a system pod actually. So what happens? That is allowed to deploy in the master node as well. Okay, that's the reason it's a 2 because I have a 2 overall 2 node. One is worker, one is master. So this is a system pod. So it's allowed to deploy in the master. But this is a user pod actually. User pod means you need a pod, not Kubernetes need a pod. So this pod will be deployed only in the worker. So if you have 5 worker, it will deploy in the 5 worker. So that's the reason it's 1. So now what the question you should ask, what made this node to not to set the deployment for the work user pod? So there is one entry which you have which is called tent. This will discuss in admin section, but let me show you so you'll understand that. Describe node. So there is a one entry which is called tent. Here you see that here, and here it says no schedule. That means don't entertain the user pod. Because of this, it deploy in the only worker. Understood all of you?
It ends.
Yeah. Now there's one more resources which have a stateful set. So what is the stateful set? So stateful set, we have certain properties. Again, using stateful set also, you can deploy the pod. That's not a thing. But stateful set API resources, we used to deploy stateful set. That means stateful pod. Okay. So what exactly you have the qualities of stateful set? So you have a 3 qualities basically. One is a pod name, create it in order and take it to the PVC. Let me put it up this way. So when you create a pod using stateful set, the naming convention of the pod will be not random, but like this. There will be one pod name standard will be there. But if you might have noticed actually, if you deploy the pod through the deployment and all, you see here, this is the deployment. See that some junk character is getting added just to make it unique, correct? Huh? Right? So that can be avoided using stateful set. That's the one thing. Now you know what? The order means creating the pod will be in order and deleting a pod will be on order. So in a deployment, what happens if you have 5 node and 5 pod, it will create parallelly each pod in each node and you will give you the results. But here first it will be create a pod 1. If it is ready, then pod 2. This pod 2 is ready, then pod 3. So this will create in order and delete also in order. So if you delete first pod 3, then pod 2, then pod 1. So this will not happen simultaneously concurrent, but it will happen in the order. Are you understanding?
Yes.
Third
So, what is the use case for this one? Like having
so
order and having.
deployment we use first for stateless pod. Stateless means like Apache, Nginx, or some software. And stateful set we use for the database or stateful. Stateful means where the data is important. That's the reason we call it stateful set. Got it? So here that way. Now last point is take it to PVC. So here because here understand this way. Pod 1, pod 2, pod 3. Now it will take to the pool of the PVC. So PV1, PV2 and PV3. Now what will happen? Pod 1 is attached to the PV1, pod 2 attached to the PV2, pod 3 attached to the PV3. So now when you delete, node get spoiled or maybe pod get issues with that. So what happened? Let's say pod 2 got deleted. So now replacement pod will be pod 2 only, and they will attach to not any other PV4 or something like that, which is available in the pool, but they will attach to the PV2 only. So it always stick to the which earlier the name and the PVs are sticky together. So that way, let's say there's an engine and there's a database, there's an engine, there's a database, there's an engine, there's data, it is already integrity is maintained. So these are the three properties which you have in stateful sets, which will make you to deploy the pod, which is stateful pod, which has certain data. So can we try this? So let me create a multiple PVs actually. How many PVs you have? Let me see. Get PVs. So I have only one PV is available. Let me create one more. So here, this is the PV1, PV2, CP3. Okay. Now DI PV PVC PV3, and this one I'll make it 2 GB, right here. So kubectl apply -f. Sorry. Now you have a 2 PVs which is available, correct? So now let's check it out. So one more, do you want me to create? Let me create one more. CP 2 4 and 4. Oh, what I'm doing? Sorry. Mhm. 4. So now you got a multiple PVs, pool of PVs, right? So I created 3 PVs. Okay, so remember the 3 is available. Now what I'll do, this is the PVs I created, so this you can leave it. Okay, 1 PV, 2 PV I created. Now 3 PVs I created, I'm using it. Okay, so now let me change this code. See, only 2 replicas I'm creating from the stateful set. This is the pod container mounting inside this, and this is the place you have to change this. So volume contain W. So as per this code, any PVs available, claim it. Okay, any PVs, and storage 2 GB. So this is done. So this is attachment of the PVC and then mounting. So can we do that? SS diss.yaml and kubectl apply -f ss yaml and kubectl get ss. I mean not ss, no, full set. So all command and all, you know that very well. See here, web 2 0/2. Just wait for a second. Must be downloading the pulling the image. Okay, you can also describe it. And it's created or successful. Look at this very carefully. 2 pod, okay. So now create web successfully. Still not ready. Wait for a second. get pods. See that? So right now, if you look at this web.0, one has not created. Web.0, which is a pending, because of that one is not created. Now, why is pending? That I want to know that. So describe pod and the name of the pod. You look at this. Now here the problem is it's not. So here it says, hey, you have two nodes available and two pod has unbounded immediate persistent volume claims. That means the volumes is not taking up because of some reason, and that is just again. So
I think volume claim name is different.
where
Volume claim name because it's
this
www.
this claim name is correct. This is storage class 1 GB. Just I'm checking it. Just give me 2 seconds. Maybe I got to know. You know what? Just a second. Because of storage class manual.
Storage
So
class.
this is a manual. Yeah. So you have to give that storage class manual here only. Here also. That is not there. So what I will do, not to worry, I'll create quickly. This is a without storage class. So PVs I'll create copy paste. So vi1.yaml and this is a 2.yaml vi2.yaml and now kubectl apply -f 1.yaml 2.yaml. Now get pods. Yes, should be taking and describe the pod. kubectl get PVs. I created this one and this one. This is pending. Described in the PVC. Set. This was working code actually last time. Let me check one more time. No PVs, but I have a PVs. kubectl get PV and my storage class is not required. No persistent volume available, which is available for this claim, and no storage class is set. I think this code got some changed with the new version of Kubernetes. So what we need to do is we need to change this part. Now we need to change this part. So just copy this whole things and get it from the official documents. That will be safer. Okay. So this is the one. So now let me add this code. Okay. To the let me add only this line, I guess. So this kind of stuff, old code, you should keep checking. So what I'll do, I'll delete this kubectl, delete -f ss, and now viss Now go to the bottom section of it and add my class name. What is my class name? Manual, right? Don't use tab space only. And here manual and save it. So kubectl apply -f ss done. So kubectl get PVs and PVs not bounded so far. Get PVC. This is pending. Still not bounding again. So let me see that. Describe PVC and this one. No storage class set. There's a
So on the
problem in
top,
this.
we did not set storage class now on the top setting.
Let's set it up actually.
Here, in the template you are setting up. Here,
Let me check one more time. Uh, www. Okay, let me try to delete that. Let me try to change this and make it without. Taking. There's some code issue. Just a second. Let me. So service stateful set claim template. This is something which I did. So kubectl get PVs. At last try, let me do that. Else I'll offline. I'll fix this code. So VISS and if we make it 1 GB, 1 GB and save it. kubectl get pv. I have these two pvs and 1 gb without okay, my bad, it was my bad. See, I created earlier 2 gb and with a class. That was the reason. So now I created the one which I am having in the pool without a class. So it should be working this time. So apply and let's see. So far not worked. Change. Okay. So this code I'll fix it offline and I'll submit you in the through the chat. Okay. Any questions anyone have?